G'day there, you're watching the Aussie BIM Guru, and today I'm going to be covering a Revit Masterclass on Revit content creation. So it's a different format to my usual video. It'll be quite similar, but I'm going to work at a slightly faster pace than I usually would in my tutorials in order to cover more advanced techniques and show you a workflow from start to finish in a way that I would usually actually do it in my real job. So we've got a previous bunch of videos on content creation. So these cover more in depth and slower the process of creating a family. This one will just show you how I create a family from start to finish. So we're going to look at creating a family all the way from template to what I would call a complete family for use. The family we're looking at today is going to be a unistrut hanger that is going to need to be a parametric family. So it needs to adjust to different sizes for different scenarios. And it has a little bit of detail in it, some nested components. So it gives me the chance to show you some techniques that you may not be aware of. So some techniques that we'll cover is how to use a line-based family, how to nest 3D families into a family. So in this case, the unistrut hanger itself will be a nested component. We'll also nest a profile into the unistrut, so we'll show you how you can do that using a profile family. We're also going to look at parametric constraints and how you can host geometry to work planes. And then we'll also look at just how to establish a basic formula and establish constraints in your family as well. How to add object styles, and also how to control the detail level and the visibility of your family. So all really important techniques to create a complete family. But without further ado, let's jump in and start the family. So essentially the family we're aiming for is going to be a little bit like this. So you've got a unistrut hanger. In this case, we use it to support ducts and things like that on the site, and then they fix this to the slab. So we're going to have a fixing height at the top and then a suspension height. So essentially you can change the fixing height, and you can also change the suspension height as well. So it's going to be quite a complicated family to set up for a basic user. So hopefully this will give you an insight into how I develop content and how you might be able to as well. But anyway, let's close this and actually get started with a fresh family. No tricks. So essentially we're going to be using some reference. So I'm going to be using this profile dimension as a reference. I'm going to omit little details like this and the teeth grooves, but I'm going to at least use this profile as a starting point. And essentially what we're going to model is the unistrut and the threads that hold these elements up. So I'm just going to make a new family. So under family, new, and I'm just going to go and find a template. In this case, I'm going to use a generic model line-based template because I want this to be a family where the user picks 2 points and that generates a unistrut in width. So we'll make a line-based family. By default, this family gives you essentially a line that the family will follow. So I'll show you how this works part way into creating this. But the first thing I'm going to do is actually establish my unistrut profile. So this is another family again. So we're going to make a new family, new family. And we're going to use a profile template as well. So we're going to have two families open at the same time. So I'll get my profile, and we're just going to draw this unistrut profile. So it's 41mm by 41mm. I'm just going to start centrically and then move it over after. And I'm just going to draw 41mm by 41mm. And in the screenshot, the lip of the unistrut is about, I'll just say that's about 10mm. Maybe, let's say it's 7.5 because it's 2.5mm wide. So I'll just draw actually let's say 10. Likewise, we'll go down and across 10. And then we want to apply a radius to some of these corners. So let's just apply a radius of, let's say, 2.5mm. And I'm using this tangent arc tool, or fillet arc tool, sorry, which can be really handy for really quickly drawing tangent arcs. What I might do then is just mirror these. So I'll just mirror this one upon its center point. What I might do is just mirror and then move it across. So I'm going to mirror it upon this snap point, then make a copy and move that over 2.5 and delete the original. Use my trim tool and trim it off like this. So essentially I'm drawing the outside face of the lip at the moment. So we'll go 2.5. And what I might do then is just take these elements, mirror them on the center point of the profile. And that's pretty much good to go. And then all we need to do is get our pick line tool and offset this by 2.5mm. And I'll tab select to get all the lines in my profile. Change my offset to 0 and draw a standard line. And there we go, that's our profile. And the last thing I'll do is move my profile over so that it's centered on the top and center. And what I'll do is just save this. But what I might do is just go to Visibility Graphics, Annotation Categories, and turn off all annotation categories. That way if a user sees this thumbnail in the library, they'll just see the Unistrut profile. So I'm just going to do a save as. I might just purge first, just to make the family as small and light as possible. Do save as family. And typically for components, I'll name them a particular way. So I'll just save this under my family masterclass. And typically for components, I like to save them in a special folder. So my naming convention is typically my acronym, PRF for profile, and then what it is. So we can say Unistrut, then I use dashes for my small break-in data, and I'll just do 41 by 41 and do a save as. And what I can do with this is load this into my family for my Unistrut. So I'm going to use this profile in the channel that forms the Unistrut. So to draw this Unistrut, I'm going to use a sweep. So I'm going to use my sketch path tool and do a pick line. And I'm just going to pick line on this reference plane. Then I'm going to use my align tool, and I'm just going to get that node on the end of the line in order to constrain the edge of this element to these two reference planes that my line-based family is constrained from. Once I finish my path, I can either sketch my path or I can load it. And now you see this Unistrut profile's appeared in our model. So essentially this lets us use this profile without having to draw it. And because we hosted it on its top and center, that's where it will be placed. Now at the moment, my Unistrut is at the wrong height. So I want this to be the level that I place my family at. So what I need to do is create a new reference plane using RP or under create reference plane. And this will be my mounting height. So what I can do with this now that I've made it is I can edit its work plane to be this height instead. So if I go edit work plane, pick a plane, and pick this reference plane, you'll see now my sweep is hosted to this level instead. And when this changes height, the Unistrut will move up and down with it. So that's how we can sort of set up a parametric relationship, a very simple one at that, just a hosted relationship really. And what I'm going to do now is associate a parameter. So I'm going to draw a dimension down to the level, and I'm going to select this and add a parameter. And I'm going to call this support height. And I'm going to make this an instance-based parameter so that every placement of this family can be a unique value. It's not locked down by the type of the family. And there we go, that's my support height. And then I can go and change this just as its default condition to say 2700. Actually, I'll do 2100. There we go. So now you can see that that moves the family around when the reference height is changed. So essentially what we can do now is we'll set up one other reference plane for our soffit height, or the top of the Unistrut hanger. I'm just going to move this up 600 millimeters and dimension this back down as well. And I want to make this, let's call this fixing height. You could use shared parameters here if you wanted to. I'm just using project or family parameters in this case. And what you could do is, if we wanted to find out what this is, note that this is a consequence of two other dimensions. So we don't want to associate a parameter to this, because essentially this is just the fixing height minus the support height. So that's our drop height, or whatever you want to call it. But in this case, we can use a formula to control this if we need it to be reported out of the family as a shared parameter for a tag, for example, or controlled by Dynamo. So what I'll do here is call this drop height, and I'll make a new length parameter as an instance. And I'll drive this with a formula. So I'll make this the fixing height minus the support height. And because it's driven by two other parameters, it becomes locked. So this is purely at the mercy of two other parameters. So as these change, note that our formula is controlling this value instead. So that's a very basic example of a formula. While I'm here, I might just create one type called typical. And the reason I'm calling this typical is because all these parameters are instance-based. So it doesn't really matter what size the Unistrut is in this case. It's just a type. So we're calling it typical because they're all going to be the same. I'll just purge. I find I purge a lot when I'm building families. It doesn't really matter when you do it. You could do it right at the end. So what I might do now while I'm still here is change these reference planes. So I'm going to make this the top of my family. And I'll just make this a weak reference plane at the moment. Okay, so what we need now is our hangers. So we're going to constrain those just a little bit in from the edge of our family. Let's say we want to inset these maybe 25 millimeters. So I'll make a reference plane and I'll just mirror this reference plane upon this line. And I'll just make these not a reference. They're just there to control the position of our droppers. And I'll just make a dimension here and here. And what you can actually do when you create a parameter is you can select more than one dimension to associate it to. So I can make a new parameter and just call it dropper inset. This one I will make type-based because we want that inset to be consistent. It's always the same. Let's make it 50 millimeters. And there you go. And now you can see that this parameter is locked down by the type properties instead. You can also lock it if you want, just by putting a number into the formula. So now this is always 50. The user can't even change it in the type properties in the project. So there we go. What we might do now is focus on this strut component that's meant to be going here. It's important to note as well that we can't actually see our channel anymore. That's because it's above the view range of our view currently. If you do need to see it temporarily while you're working, you can actually select the floor plan and change its view range. Note this will have no impact on your family in the project. It's just in your working environment if you need to see these elements, if they're too low or too high outside the view range. So I can say my view range is 2100 up to 2700, and there's my channel. Now I can see it again. What I might do is just save this family, assuming I'm working on it and I don't want to lose it, because occasionally programs can crash. So in this case, I'll just call this Aussie BIM Guru GEN for generic model. And I'll just call this Unistrut hanger type 1. I like to usually say type 1, type 2. That way, if you end up with variations upon the family, there's still a way to identify the difference between them. Okay, so let's start making our dropper now. So I'm just going to make a new family again. And I'll make this a generic model. And we're basically going to build this as what I like to call a component, which is a piece of a family that you can load into another family, but it doesn't become a part of the project. It's just part of the family. And the thing that's pivotal to this is this box called shared. So if this is ticked off, the next level you load this family to is essentially the end of the line for that family. So if this dropper is going to be loaded into the Unistrut family, when that Unistrut family is loaded into the project will see the dropper as geometry. It won't actually give it its own nested family in the project level, which is ideal because we're really just building the Unistrut for control in this case. So not the Unistrut, the dropper. You'll note too I've turned on the work plane based property here. So I'll show you why I've done that in a second, but I usually recommend turning this on for a majority of families. So for this family, I'm going to go into front view. Actually, I might go, front view first. So I'm going to make this the level of my Unistrut. So I know that my Unistrut is 41 millimeters high. So I'm just going to put a dimension on here at 41, and I'm just going to lock that. And this is really just a guide for my family. Likewise, I'll make a parameter or a reference plane for the top or my slab. And I'll dimension that off the top of the Unistrut. And I'll just call this height and make it an instance-based parameter. So now what we want to do is draw some components for our Unistrut dropper. So typically these elements will typically have a plate above and below the Unistrut. They're all different, of course. They're not always the same, but I'm going to do this scenario. And then a bolted thread that runs through the Unistrut up to the top of the slab, where it's typically either bolted, chem set, or fixed to the slab somehow, or it's clipped onto a beam. But essentially what I will focus on in this case is just this fixing first. And it's all hosted around this reference plane, really. So what I'm going to do is go to floor plan, and I'm going to draw an extrusion. And I'm just going to make it 41 by 41. Let's make it the same width and depth as the Unistrut. And what I'll do is just trim this up. And I'm just going to move this over so that it's always centered on these two origin reference planes. That way when I place it, it's all centric. So I'll go to front view. So currently this is hosted to this reference plane. I can actually host this to another reference plane if I want. I can say host here instead. And note that your extrusions always have a start and an end value. So what I can do is say it starts at 0 and finishes at -10. And now you can see that this is instead still hosted to this reference plane, but now it's being downset instead. Likewise, I can put one on top by picking plane and picking this reference plane and setting this to 0 and 10. or 0 and 5, depending on what thickness you want your plate to be. And you can see you can work both ways in respect to the reference plane as well. But in this case, I'll just do 2 square plates, and I'll just do one at the top as well. Let's just do a bolted connection like a chem set at the top. And we'll do -5 for this one. And then as this reference plane moves, so will all these elements that are associated to them. So if this moves down, my bolt moves down with it, and I don't need to do any constraining. It's just based on reference plane relationships. Let's add some bolts as well. So I'll go to create extrusion. And note you can also change your work plane here when you're drawing as well, and pick a work plane at this point. For now, I'll just keep drawing as I was before. I'm just going to use a polygon with 8 sides for a bolt. And I'll just make it 10 mil in radius. So if I go to front view, you can see now we've been drawing off this reference plane. Now I want to be 5 mil up and then 10 mil up, so that I start on top of my plate and finish 5 mil above that again. Likewise, I'll rehost my work plane to the bottom and then do -5, -5, -10. So it's all about relativity to the work plane. I can also do one for my top connection with a pick plane up here, and there we go. So now we have bolts on all of our plates as well. So now we'll add the threads. So it's important to note that I'm going to make this a top hosted unistrut. So I'm going to do a 2.5 mil reference plane here. And this is so I can host my thread and make it look like it actually stops when it meets the unistrut. So I'm going to make a thread, and I'm just going to make this probably let's do like a 7.5 mil thread, 3.75 diameter. Actually, maybe we'll make that a little bit bigger. Sorry, a 5 mil radius. Okay, so now you can see currently we're hosted to here. So what I might do is use my align tool, tab select, and align my thread here and here. And while I'm still in this view, I'll use CO for copy, do an offset of 0, and then I'll rehost another part of the thread to here. So because I'm constrained to this reference plane, I can set the start at 10 mil, but I'll need to constrain at the top. So what I'll do is just copy down by 10 mil, set it to not a reference, and just dimension and lock this at 10 mil. Then I'll constrain my thread up here. So that's pretty much the thread created. So that's what we've made right there. And this means we can now place 2 of these really easily in our model. So I'm just going to purge. And what I'll do really quickly is just set up an object style for this thread that will be associated at the next level. So what I'll do is just call this thread. You could call that unistrut and make it a part of the next level of the family. It just depends on how you want to control the visibility of these elements in your family. What I'll do is just also associate a material parameter. And I'll just call this material and make it instance based. That way I can set it at the next level of my family when I nest this within my unistrut. But essentially that's all we need to do. And I'll just call this typical. So now we should have a parametric family, or a parametric strut that we can nest into our unistrut family. So I'll do a save as, save this thread, and I'll just call this, I'll put a little -c because it's a component. That's usually my standard that I use, so people can tell when it's a component family or a project family. And I'll just call this unistrut thread type 1. I'll just load this into my unistrut family. And notice because I've used a work plane based family setting, I can place on a face or a work plane, and I can pick my work plane very easily. So note that we don't have our support level available as a work plane at the moment when we look at that list. That's because we haven't given it a name. So let's just give it a name. Let's call it support level. What I can do now is take my 2 threads, edit their work plane, and I can pick support level from my list now. And now you can see that they become hosted to that level, and because I've based my family from this level, you can see that this is how it will situate itself around the unistrut. if I go to floor plan, I can use my align tool and I can align my family based on its center planes. Likewise, I can align this one and this one. And what we should end up with is a pretty smart looking family that has a detailed unistrut that's still parametric and connected to all these elements. But the one thing we haven't connected here is that these threads are currently flexible. But remember that we created the parameter for the drop height based on this formula. So you can actually nest this into the height of the unistrut. So even though it's driven by a formula, you can use that formula to drive other elements. And now you'll see that this remains parametric. So when we raise or drop our unistrut, you'll see that our components also follow this height as well. So really smart. And what I can also do is now I can take these two struts and nest a material parameter in here. So let's just nest an instance-based, actually type-based material in this case, because we're in the unistrut itself. And I'll just also nest that to the channel as well. Note that because we're working in the same category of family, our thread object style has come through to this level of the family and will also reach the project. I might also just make one called channel. And channel, I'll use for my unistrut channel. Now these two elements, I don't want to see them in floor plan. I don't really want to see my unistrut channel as well because it's too detailed. So what I'm going to do is go to the visibility graphic overrides of these elements, and I'm going to tell it not to show up in floor plan or RCP. What I might also do is say that I only want to see my threads when I'm on fine detail, because they're quite detailed elements. Note that this channel is also quite detailed. So maybe I want a simpler version for when I'm not in fine detail view. So when I'm not in fine detail view, let's just say we want to see a box. So what I'll do is say that in coarse, let's say in coarse we don't see this detail. In medium we do, but we don't see the threads. So what I'll do now is just model a new extrusion, and I'll model it at support level. I'll constrain it to either end, and then I'll just set two lines that are non-constrained for the edges. There's one, and there's the other. I'll just trim these lines up. And I'll just give it a negative offset of 41 millimeters. That way it's always sitting 41 millimeters below. So obviously we have geometry on top of geometry. What I'll do is just say this doesn't show in plan or RCP, but it only shows on coarse detail. So we only ever see one or the other of the representation. We'll set its material and also its object style as well. A good tool when you're editing families, if you want to see how your family is going to look at various levels of detail, is down here. So this is your preview visibility. So let's just turn on preview visibility. So now we can see that we're at medium, and all we see is our unistrut channel. We don't see the droppers and we don't see the coarse representation. Let's go to coarse. Now we see the really simple representation, and at fine we see everything. So we see the channel and we see the droppers. Excuse me. And we don't see that coarse representation of the channel. So that's how you can control the level of detail and element filigree that you see in your model. Anyway, the next thing we'll do now is that at the moment we can't see our channel in floor plan. So what we need to do is add some annotation lines. So I'm just going to go and draw some annotation lines. Note that annotation lines can be drawn at a level. So I can still say that they occur at support level so that the 2D hierarchy of these elements is still understood when it finds other 2D families that it meets. I'll just make this the unistrut channel object style, so the channel, and I'll just make them not a reference. Note I'm doing this all before I even draw. So I'm just going to draw these and use my align tool to lock these two. And all we'll see in floor plan or RCP for this family now is 4 lines. So we're already showing a lot less detail, which will speed up our floor plan and make this family a lot faster to see, especially when you have a lot of them holding all your ducks up. So just keep in mind that sometimes it's better to do 2D representation in 2D views. You could do the same in elevation. In this case, I won't. So the last thing we'll need to do now is add an invisible line, because if we have this family placed in our model, but there's no geometry underneath it, if this is above our view range, we won't see those 2D lines. But if we add an invisible model line that's cut through, the family will think it's been cut and it will show the 2D lines. I might just show what I mean. So if I just draw an invisible line and make it not a reference, this all doesn't matter because it's invisible. I might just draw it and I'll host it to the top of the family all the way down to the reference level. That way the family is always cut at some level, because 3D families will show their 2D elements as long as they're cut in some form. So that means when we're in floor plan, we'll see our unistruts above us in floor plan, which is usually ideal because you'll be seeing them on duct runs, for example, which you also want to see in floor plan above. So we're pretty much almost done with our family at this point. Hopefully it's been useful seeing some of the techniques I've used along the way, and I'll show the family in practice. What I might do here is just add a material to the actual unistrut family itself so that it renders okay. So what I might just do is look for a galvanized steel from the Autodesk material library. So I'm just going to search for galv, and I believe there's some galvanized steel in the default library. The material browser can be a little bit slow sometimes. There we go, galvanized steel. So I'm just going to add this to my family, and I'll associate that to my material. There we go. So now we have a material associated to our elements. Cool. I'll also make sure that my family is shared so that when it's in the project or it's nested into something else, it also reaches the project as a nested family. And that way you can still tag it and schedule it even if it's nested into another family. I'll do another purge, and we'll just add some basic information about our family as well. So you can add a type image so that if you schedule it, you can add an image for it as well. In my case, I'll just add one of these images. Keep in mind this should come off the server path so that everyone else has access to this image when they load the family. But I'll just pick one of these images. Cool. Great. It's ideal to make it a small image as well. And we'll just call this US for Unistrut for our code. Model, if you know who manufactures it, great. What I usually do with these, if I don't, is I lock in a generic manufacturer. So it forces the user to open the family and actually think about it. Cool. You can also add a URL if you know a website to link this to. So we could say Unistrut Australia. And I could link this URL. Then when you're in the project, you'll have a hyperlinkable URL. So I'll just copy that. Okay, it looks like it's not committing to my keyboard. There we go. Okay, I'll just do it manually. Unistrut www.com.au. It's been tricky today. Cool. And if you want a description, you could call it, say, Unistrut 41 by 41 millimeters. If you know an assembly code for it, feel free to add it. And if you know a cost, you can do that as well. But in this case, we don't need to do either. Note that cost is a tricky parameter to work with because it's type-based. So if your cost is based on a formula, say the length times something else, and it's not a type parameter, you can't really connect it to an intelligent cost, which is a bit of a shame. But essentially that's all we need to do. So if we OK that, I'll show you how this family works in the project. So we'll save and we'll just open a new project. Just an architectural template. And let's just have a look at how it behaves. So it's a line-based family. So it immediately prompts us to place it on a work plan because it's a line-based family, and we'll basically be able to click twice and it will generate a unistrut. So if I zoom in, we can see those 4 symbolic lines that we use to represent the family in floor plan and RCP. And essentially at this point, you can just change it any way you want. So that's the power of line-based families. Sometimes they're great. Let's just jump into 3D and have a look at it. So we're only in coarse detail. Sorry, we're in medium detail at the moment. So we can only see the unistrut itself. Let's go to coarse. Now we see the box. Fine. And now we see all the detail. So let's say that I need to make this 3000 above the floor for fixing. All I have to do is adjust my parameter, and you'll see that those struts change in height because they're controlled by the drop height, which is connected to the formula. Likewise, I can also change my support height and it all recalculates. So a really smart, easy little example of some family techniques on display there. The last thing I'll show you is those object styles we set up. So object styles allow you to have more control over the visibility of your elements. So let's say that in 3D we don't want to see our threads, but we want to be on fine detail. So I can go and turn off thread, and my threads are turned off. Or maybe I want to change their color. Maybe I want to make them gray, and I want to make my unistrut channels blue because I'm doing some coordination. I can just quickly override those two subcategories, and there you go. You can see we have a lot more control over the way that our family looks. And because we've made this family instance-based, it's important to note that you can independently change the properties and they won't impact one another. They're independent. Also in floor plan, let's say that we're seeing those unistruts and we don't want to see them coming up as solid lines. The great thing about object styles is you can really quickly go and change the graphics of an element just in that particular view. So we can say that our unistruts are always dashed because they're above. And if our scale is small enough, you can see now our unistrut object style is being overridden. So really cool, right? So a lot of little techniques on display there just to save you a bit of hassle in establishing some things like this that can really help enhance the quality of your model, but also make the families easier to use for your users, because essentially effective families need to be easy to use, but they also need to achieve the job that they're required to do. So that's why I've added a lot of controls and a lot of smarts into the family, and also detail level controls so that they work at different levels of detail review during the design process. So hopefully that helps. But hopefully I'll do some more of these at later dates, not just for families, but also for design and modeling workflows as well. So that's all for today. If you've got any feedback or comments, or just recommendations for future masterclasses I can conduct, feel free to let me know. I make videos about 2 to 3 times a week, so I try to upload quite frequently. So if you're not already following and subscribing, feel free to do so, and hopefully I'll see you in the next video. Thanks, take care.